We're still doing our optimization, and we're trying to optimize some business applications. So this is just a real quick review of what we did with the business problems. X was the number of units that we produce or sell. Lowercase p is the price. Capital R is the total revenue. Capital C is the total cost. And capital P is the total profit from producing X units. Remember that to find the profit, we have to do revenue minus cost. So in the first problem, it says, in marketing a candy bar, Hershey has discovered that the demand for the item is represented by this price function. So remember, our price function has to always be based on the demand. The cost of producing X items is given by this function here. C equals 0.5x plus 500. Find the price per unit that yields a maximum profit. Okay, so we've already done this before, but it has been a while. All right, so let's look at how we're going to approach it. So looking again, find the price per unit that yields a maximum profit. So we're going to need to find our profit function. So our profit function, looking up here, profit is going to be revenue minus cost. Well, revenue is X times our price. So right here's our price function. So to find our profit function, we're going to have to do X times 50 over radical X. That's going to give us our X times our price, and then minus our cost function. So if we're trying to maximize our profit, we need to simplify it first, and then we're going to need to take the derivative and set it equal to 0. So simplifying this, if I have X over radical X, that's just going to give me 50 radical X, and then distributing this negative through, and I'm going to think of this as being X to the 1/2 so that I can take the derivative of it. So there's my simplified profit function. So taking the derivative, we're going to get P prime. 50 times 1/2 is 25x, subtract 1. This derivative is just going to be minus 0.5. So what did we say we do after we take the derivative if we want to maximize? All right, we're going to set it equal to 0. So setting this right here equal to 0, I'm going to have 25x to the negative 1/2 minus 0.5. So I'm going to take this over to the other side. 0.5 equals 25 over x to the 1/2. I'm going to cross multiply. Come up here. So when I cross multiply, I have 0.5x to the 1/2 equals 25. So what are we going to do to solve that then? What do we do to solve that for x? Yep, divide by 0.5. So now I'm going to have x to the 1/2 is radical x. Let's see what 25 divided by 0.5 is. If you don't know, grab a calculator. It is 50. So we have radical x equals 50. And so now if I want to solve for x, I'm going to have to square both sides. So if I square both sides, x equals 2500. I could double check and make sure that that is indeed going to be the maximum by taking the second derivative and making sure that it's a negative. But these problems are designed that if we get one answer, that's going to be it. So I'm not going to concern myself with that. But I do want to make sure that that's what I'm looking for. The question says find the price per unit. Does X represent our price? No, that's going to be the number of items we should produce. So I have to go back up here to P, lowercase p. So the price is going to be 50 over the square root of 2500. And the square root of 2500 is 50. So 50 over 50 is $1. So that's the price that they should charge in order to maximize their profit. Questions on that? All right. Let's go on to number 2. This type is always a bit difficult for people, so make sure that you watch closely. A real estate office handles 40 apartment units. When rent is $600, all units are occupied. For each $20 increase in rent, one unit becomes vacant. Each occupied unit requires about $30 per month for service and repairs. What rent should be charged to obtain the maximum profit? So here's what's going on. If they charge $600 for the apartments, all the units are occupied. So there would be 40 units that are occupied. But they want to know, okay, what if we raise the rent by $20? Well, now how much are they going to be charging? $620, but people say, hey, I'm not going to pay that much money. You raise my rent. You know, one person out of the 40 says, I'm not willing to pay that. So one unit becomes vacant. So now they're going to have this revenue. So this was their revenue, now it's this. So what if they take it up another $20? Now how many are they going to rent out? 38. So this represents their revenue, but they would also have to subtract their cost. So the people who own these apartments, they have to pay out $30 per month for each one that's occupied. So in this case, it would be 30 times 40 that we'd have to subtract. In this case, it would be 30 times 39. This case, 30 times 38. So look again. It's price times X minus cost. That's what we're doing. So the question says, what rent should be charged to obtain the maximum profit? Well, I'm going to let X equal the number of $20 increases. So X is going to equal the number of $20 increases. So I could do this 1 time, 2 times, 3 times, 4 times. I could get it up to $800 if I had enough $20 increases. So let's try to come up with our profit function now. So normally I'm going to have $600 that I make, but I'm going to increase it by multiples of 20. So what's my price going to be now? It's not 600 plus X. What's it going to be? 600 plus 20X, right? So this is going to be how much the price is going to be for those apartments. Now, what about the number of apartments? Well, normally it's 40, right? So normally it's 40. But what's going to happen every time I raise it up by $1 $20 or $2 $20 or $3 $20? Subtract by 1. So this is going to be what? Minus just X, right? Minus our cost. Well, our cost, we have to pay out, or the owners, whoever we're thinking of this as, they have to pay out 30 times how many apartments are we going to have rented out? 40 minus X, excellent. So this would be our profit function that we're trying to maximize. So I'm going to have to multiply this out. 600 times 40 is a 24 with 3 zeros, minus 600X. This is going to be 8 with 2 zeros, X. And this is minus 20X squared. Then we also have to combine this, so this is minus 12 with 2 zeros and plus 30X. Distributing that out. Okay? So this is going to be our profit function. Let's simplify it a little bit more. Let's see, 24,000 minus 1,200. So I have 22,800 with these two. With my X's, I've got 200 plus 30, so that's going to be 230X. Those are gone. And then minus 20x squared. So there's our simplified profit function. So now I'm going to take the derivative. The derivative is going to give me 230 minus 40x. Now what do we do? Right, set it equal to 0. Bring over the 40x. 230 divided by 40 gives us 5.75. Now, we have to do a little thinking here. 5.75 is exactly what we should do. It's going to maximize our profit. You should stick with x equals 5.75. But we're going to plug that in now. So we're going to plug it in here because we want to know what's the rent. Right here's the rent. This is the number of apartments. This is the rent. So the rent is going to be 600 plus 20 times 5.75. So 600 plus 20 times 5.75 gives us $715 is the rent. And sometimes people say, yeah, but how can you do 5.75 because you couldn't rent out 40 minus 5.75 apartments? Well, no, but what does that mean if we get 5.75 for x? What's it mean as far as the number of apartments that we're going to rent out? It might be 6, but it might just be 5, right? Because we didn't take it up a true other $20. You know what I mean? This is just kind of like an estimate of what's going to happen. You know, maybe they did a survey and said, hey, if we raise your rent, are you going to stay? Yeah, I'll stay if it's only 20, but if it's 40, then 2 people say, no, I'm not going to. You see what I mean? So we do not want to round this x value. We just always want to substitute it in because that's the rent that's going to maximize it, regardless of how many apartments are rented out. All right, let's go down to the last one here, a cylinder. There are lots of items that use cylinders. When we go to the grocery store, we were talking about that yesterday, about cereal boxes are always prisms. Soup cans are always cylinders. They're always these kind of common shapes. Actually, soup now, sometimes it comes in as a prism, doesn't it? Like the box of soups. Do you guys see those now sometimes? Yeah, I don't know, that's kind of a more recent thing, but probably makes it easier for the packaging and distribution and everything. So anyway, it says, what are the dimensions of the soup can of greatest volume? Now, I'll tell you, that's not really what manufacturers are usually going for. They're not usually going for the greatest volume. Like we talked about yesterday, they want it to look like a lot, but maybe not necessarily be a lot. That can be made with 70 square inches of tin. All right, the entire can, including the top and bottom, are made of tin. And what is that volume? All right, so we have to think about what our formula is for the volume of a cylinder. Does anyone remember the formula? It's always area of the base times the height. Yeah, Jeremy? Right, pi r squared times h. So that's what we're trying to maximize, is our volume. Now, this is where it gets a little bit tricky. What are the dimensions of the soup can that can be made with 70 square inches of tin? Well, that's telling us what the surface area is. They're telling us that the surface area of this cylinder is going to have to be 70. Now, how do we find surface area? Well, here's the way it works. We know that surface area is going to have to be around that part of the can that's called the lateral area. I'm trying to create this to make it easier to understand. So look, guys, if I wrap this around like so, and then I take this off, what kind of shape does this become? A rectangle. How do we find the area of a rectangle? Base times height. So the base of this is the same thing as what? Circumference. Excellent. So I know then that it's going to be the circumference, which is pi d times h That's going to tell me what's called the lateral area for this part that needs the 10. And then what's the area of the top? Pi r squared. And the bottom? Pi r squared. So what am I going to add on to this for the surface area? Plus 2 pi r squared. Yeah. I mean, you can memorize these formulas, but if you understand them, it's so much better. All right, so here's what we've got. How can I write d, though? Instead of using d, I can use 2r, right? So my surface area then is 2 pi rh plus 2 pi r squared. That must equal 70. That's how much 10 I have. So what we want to do is we want to solve this for h. Because remember how I said we have to have just a single variable if we're going to take the derivative? So I'm going to solve this for h, and I get 2 pi rh equals 70 minus 2 pi r squared divided by 2 pi r. And that's going to be what h is. So I have to take this and plug it into my volume formula. So I have V equals pi r squared. H is 70 minus 2 pi r squared over 2 pi r. These are the tough ones. Remember how cones were the tough ones with related rates? Cylinders are pretty tough with optimization. All right, so now I'm going to have to simplify this. I'm going to distribute this through. So if I have 70 times pi r squared over 2 pi r, I'm just going to write that out. 70 pi r squared over 2 pi r. And going to the next one, I'm going to have minus 2 pi r squared times pi r squared all over 2 pi r. Do you see what I'm doing? Just distributing this out. Simplify it now. 70 over 2 is 35. That's going to be 35r. This one, I can cancel one of these, those, and that. So that's going to be what? Pi r cubed. So all of that stuff is just going to simplify down to the volume is 35r minus pi r cubed. It's not that bad now, is it? So what do we do with this volume? We have to, what do we do, guys? Take the derivative. So 35 minus 3 pi r squared. And set it equal to 0. Add this over. 3 pi r squared equals 35. So now I'm going to have to divide by 3 pi. So r squared equals 35 over 3 pi. I'm going to have to take the square root of that whole thing now. Well, so second square root of 35 divided by parentheses 3 pi. Got to be careful with that, guys. I have to use parentheses around that 3 pi so it divides by the whole thing. And I get 1.93. So the radius is going to need to be 1.93 inches. Let's see what it says. What are the dimensions? So the radius is 1.93 inches. If I want to find the height of it, oh, where's my height? Right here. Here's my height. So watch how I can type this in, guys. I can do parentheses 70 minus 2 pi. I'm going to put that last answer in there. Get that in there. It has to get squared. And then divided by parentheses 2 pi. And then there's my radius again. I'm just going to, that's my last answer, so I don't have to type in that number. And there's the height. Tough stuff there, but just practice typing that kind of thing in. That's 3.85. So there's our radius, there's our height. It asks us to find the volume. So to find that volume, I have to do pi Watch this, guys, how you can use this calculator. There's my radius, so I need pi r squared times, and then here's my height. I can plop that right in there too. And it's 44.97. So you want to try to get to where you don't have to round a lot. It's cubed. Okay, so I tried not to round at all, and that's why I went up and got those last answers and just plugged them in there. Okay? I don't think you'll have to do a cylinder because you're just doing numbers 1 through 5 on the worksheet. All right, good job.